Hi, this tutorial is about how to take your Terraform game to the next level and to write sustainable infrastructure as code. And to do that, we're going to diagram, we're going to have a hands-on walkthrough, and you're going to see how I think and how I operate when I'm building these repositories out. I know a lot of these tutorials, when you first look at them, they have a lot of magic in them, and you see that folks suddenly have these clips of code. We're going to bypass that and actually do it for real. So what I think we're going to try and set up today is a Terragrunt repository. I'm going to explain what that is and how that works, a Terraform module catalog, and I'll pull something together off the web, and then maybe we'll deploy out something with a Helm provider on top of that. And hopefully with these three different components, with the Terragrunt, Terraform, and the Helm provider, we can actually create a cluster and deploy something out on that cluster. This is useful, especially when you're working inside the SRE or DevOps space, because it's usually pretty complicated to figure out how to get these things going, and there are rarely tutorials that are comprehensive. There'll be like a 101, or there'll be something that roughly covers it, or there'll be a really in-depth guide that perhaps doesn't quite start at the right level. So I hope there'll be something for everybody in this video, and I just want to cut now to effectively what will be the diagram to show what we're going to do today. So starting off, we're going to create a Terraform repository. That repository is going to have inside of it a module or a bunch of modules. And this is the new way we have to think about Terraform. Rather than being a plan of our environments and our infrastructure, we want to think of Terraform more as just a module catalog, right? So your catalog might have something like EKS in it, or you might define that as Amazon. Depends what sort of baseline you want to start at. So I'm going to pick a really simple example. I'm going to pick Civo. It's a cloud provider, has Kubernetes inside of it. I'm going to make a Terraform repository. I'm going to have a Civo module inside of there, and inside of that module I'm going to have effectively a Terraform cluster.tf, right? So inside of that module will be a cluster.tf, and the idea is that all this repository does is it creates the resources inside this folder when I point to that module. I might later on want to extend this and say, you know what, I'm going to bring Cloudflare into the mix so that I can do DNS at the same time. And this is where traditionally in Terraform you have to start hard coding environments and variables and copying over, because there's no way to replicate this for different environments without copying over the TF files. So as you might have started to guess, we're going to figure out how to get past that with Terragrunt today. So let me just give another example here. So DNS.tf. So if I have a staging environment versus a prod environment, those have completely different configurations, and this is where Terragrunt comes in. Terragrunt is effectively an HCL-driven repository that connects to your Terraform repository, and it drives those modules. So let's think about it in terms of the environments. So you could have staging. You could also then have your production environment, right? And staging might not do DNS entries, right? It's possible that we have different kinds of DNS entries in staging versus production. But in our example, let's just say that production does DNS updates and it does cluster deployments. So this is fairly different to our staging example, which will only do the cluster deployments. Let's say the staging cluster might deploy to a fixed DNS, whereas production might be on a wild-carded suffix or prefix even. So let me just highlight that here. So that's our staging environment, and here we have our production environment. Cool. So let's figure out actually how we're going to build this. For the sake of the demonstration, I'm not going to push these repositories to the remote, because I would then have to set up the Git repositories. I'd have to figure out during this video where I'm going to put them. So in fact, what I'm going to do is I'm going to create some repositories. I'm going to call them make directory. I'm going to call it cn skunkworks terraform. Make directory cn skunkworks terragrunt. So let's start with our Terraform repo, right? So we're going to jump in there. I always think it's great if you can pull stuff that you've already got into these things. In my case, I think I have some stuff in my personal repository, so we're going to make that cluster TF. But before we do that, let's create some of these example kind of DNS entries. So, example kind of modules. So let's start with my Civo module. I'm going to then put inside the Civo directory a cluster.tf, right? And I'm going to pull this right out of my own repository, and I'll put all the links in the video at the bottom if you're interested. Otherwise, this will be a complete example that you can go off and download. So if I grab my Terraform Civo, which is something I wrote before, you can see I've got a bunch of stuff in here. So the core things that I really need in any Terraform module are going to be the resource. So this resource here is really simple. It has the cluster object, and then it has a data object for determining the cluster size. and then it has a data object for returning the cluster itself. So let's just figure this out. I'm just going to set that up. Okay, so I've got my cluster TF. What else do I need? Well, you should probably touch an outputs.tf, and you should probably touch a variables.tf for this to be syntactically correct when you run the linter over it, because sometimes that can really complain. So let's go back. What else have I got in here that might be useful? I have a provider. The provider is useful. That's great because I can effectively set up Helm and Kubernetes inside this cluster once it's deployed. So I'm going to just grab this whole file and I'm going to copy it over. So provider.tf. Great. And I can see there that my bottom piece, so my top piece here, the provider takes a Civo token, right? So that could be an AWS token, that could be a token for any cloud provider, but I just have to bear in mind that I probably want to define that in my variables.tf. So if I just go back into here and I define a new a new variable, I'm going to call that variable Civo token. I'm going to go in and call that default equals nothing, the type equals string, and the in fact I'll leave a blurb for now. So there's my my Civo token. What else do I need to do? Let's have a think. If we go back to our provider, that looks okay. We've also got our cluster. Now let's see what I've done in my little repository here. I think I've got a few parameters set. So for the sake of argument, I'm going to see what I actually need. So I think the cluster name, the nodes are all I need for now. So I'm going to copy those right over. Okay, so what we could do just to test if this is syntactically correct is we could try running a plan. Now, because nothing's initialized, I would have to run an init first, and that's okay because the init will produce a local TF state, it will pull the modules down, but when we work with Terragrunt, it sorts that out itself, so you don't have to worry too much about this polluting the workspace. It's more just to check that, can I actually pull these things from the remote, and is that working correctly? So this is about all I'm going to use my personal repository for. At this point, you can see that I've passed in Terraform variables, but we're going to do something a bit differently, right? We want to set an example where we're using Terraform and Terragrunt. So we go back to our example here. We're going to think about setting this bit up now. I've neglected putting together the Cloudflare example, but we can come back to that in a minute. The important part is that we actually figure out how these two things connect together. So I mentioned that these are local repositories. Let's talk about the next steps here. So how do you set up a Terraform repository versus a Terragrunt repository? Because they are different things. So let's go over and jump into our Terragrunt repository. Okay, so there's nothing in here. We're going to create a staging environment, and we're going to create a production environment. Now, the way that Terragrunt works is that it effectively uses the Terragrunt HCL files to navigate around the file system. And these are clever because it lets you have structured folders that have a terragrunt.hcl that will be able to read back up to the root file when you use a particular type of includes. Now, if you want to learn more about Terragrunt, you can just jump into the Terragrunt website, and there's some good getting started docs. However, I found that it takes a little bit more than what's in this documentation to really get going. For example, this can seem a bit overwhelming when you're reading this first time round. It's not particularly clear to me where this goes. I also don't know, like, is this for just a single module? Is this for multi-module? So let me just explain it as clearly as I can. So from the root directory, we're going to have a single terragrunt.hcl. And this is kind of like our driver for everything else. That Terragrunt HCL is going to be injected into the modules that we are defining in our environments. Typically, in an organization, you might want to say something like this. Production is an environment, and inside the environment, you have a module. So remembering what we had in our folder here from Terraform, I'm going to say the module I want to use today is called Civo, okay? So you could have another module called EKS, or you could scope it to a cloud provider and call it GCP or AWS. But in this particular case, I'm using the Civo cloud provider. I'm just going to call my module Civo, and that's mapping directly, right? So there'd be the environment name and then the module name. So let's go staging Civo. So I've got my two modules inside of my environments. So let's look at the production Civo environment. So what have I got in here? Nothing, right? So let's create a terragrunt.hcl file, and we'll do the same thing in the staging environment. And why is this important? Well, it's important because we can have contextualized information, right? These two modules, or these two files that are defining which modules to use, are going to be full of different inputs. And as you can see on my screen on the left in this example code, they're showing you how effectively these inputs override the variables inside of your Terraform module. So these map one-to-one. So let's think about what do we need to do to set this all up? Well, I mentioned a moment ago that I don't have these repositories pushed anywhere. And one of the key parts of this is that Terragrunt likes to pull from a remote repository. Now, for development purposes, I can do something local where I can actually source from a local directory. However, when I've pushed at the end of this tutorial, I'm going to want to have it in a remote. So that's where the top bit comes into play. So let's start thinking about how these Terragrunt files work. I've got my structure and I have this root terragrunt.hcl. There's nothing in it. So what do I need? First and foremost, you need to have a provider. A provider is generated through Terragrunt and gets injected into Terraform modules. The way this works is it checks out your Terraform module at a tagged version or at a SHA, and then it overwrites your provider.tf file if necessary and puts in the necessary data. So we have a provider TF file already. So how does that come into play? So let's have a quick look. So our provider TF file looks pretty good. Doesn't look like there's anything that really needs to be overridden inside of here. So I feel pretty comfortable that at the root level, we don't need to do anything in particular. However, there's one thing that we've neglected. We've not really spoken about or thought about workspaces. It doesn't make much sense for each one of these folders inside of Terragrunt to maintain state locally, right? Because the TF state file, we'd have to then commit into Git. So what we can use in the Terragrunt HCL file is we can generate a backend. If you're familiar with Terraform, you'll know that you typically would have a backend in your Terraform project. So we could inject a backend at a module level. And that's kind of interesting because that means that we can have a workspace for each module within each environment. So we have two workspaces, right? So I would have effectively staging, Sivo, staging, Cloudflare, production, Sivo, production, Cloudflare. Now, I'm pretty keen on using Terraform Cloud, purely because we've had a lot of success. I'm going to switch over to my personal account and I'm going to jump right in and I'm going to create those environments. So let me just open up my 1Password and let's get this going. There are many advantages to using a remote state versus local state, one of which is that it's a lot more compatible when you've got a larger team because you can have a remote lock. Again, folks might say, why would you use this over something like, S3 bucket? Sure, you can use a bucket, but again, this gives you traceability back to the commit. You can also look at the resources in the UI, and we'll go on to look at that in a moment. So I'm going to create some workspaces. I'm going to create a, let's think, staging-Sivo, okay? And I'm going to create, I think that's probably okay for now. We'll leave that for now because we'll run that as our first test. So the other thing that I'm going to do on here is because I've got variables that are being injected from Terragrunt, Terraform Cloud doesn't understand what Terragrunt is or what it's doing, so I'm going to set it to run locally. So when I do a Terragrunt plan and it invokes the workspace, it's not going to try and run it in the cloud. So there we go, it's going to run locally. And this all might seem a bit unusual, but if you bear with me, I promise it will make a bit more sense. So the thing that we want to do now is we've defined these remote workspaces, is how are we actually going to inject those remote workspaces when we check out these modules? Well, that is where the root level Terragrunt HCL file that we have is going to generate the provider. Now there's a problem here, right? How do we dynamically tell it which environment we're in? And that is where I like to have a regional or an environment.hcl in each folder where you can store these kind of variables. So before we go into the root level, let's have a think about what that might look like. So if I go vim production terragrunt.hcl, and remember you can have these files inherit, and when it sees them at each level it will pull them in. I'm going to define some locals. So one of my locals might be something like my environment name. So we could say environment equals staging, right? Let me just correct that because I was in production. And then let's do another one for staging. So we're creating a new terragrunt.hcl, and you know what? Let's just modify the name for simplicity. So if I go to environment equals staging, I'm going to rename these files just for context. So the name is arbitrary, but let's call them environment specific.hcl, right? That makes a bit more sense. Okay, same thing as we're going to do that for prod. So these are going to be parameters and variables that are specific just to that environment. And there'll be things that you're not defining at the module level, but there'll be things at the environment level. For example, there might be an environment key, right? You might have an AWS key for that entire environment, or you might have, in my case, a name as a prefix for that environment. Okay. So now if we look again, you can see that we've got our module level parameters, our then environment specific, and then our root level. That's looking pretty good. So I made another video on this a while ago, and I think this is part of a meetup. So I'm just going to cannibalize something I've already got, which is something I would really encourage anybody to do. You know, don't try and reinvent the wheel here. So let's go and look at, I think I had Terragrunt as an example. Yeah, so this is a configuration I wrote. Okay, and I've got a little example here, and I'll put this in the video. Feel free to take any resources that are useful. So we have a similar situation. We've got New York and London, right? And in London, I have my regional config. Here, I've called it something slightly different, but effectively, you can see you've got locals. This is kind of a nice touch here, is that for the CVO token, I have put a getenv in. And that's cool because on my local computer here, if I look at my my Zush config or my bash RC, I think I have that token set. I'm not going to paste it here because there's some pretty sensitive stuff in there. So let's go in and do something similar. So I'm going to go to staging. I'm going to go to my, what did I call it? Environment specific config. Let's add that in. So what this is doing is it's setting the CVO token to that getenv. Now that CVO token doesn't mean anything at this point because we're not chaining it together, but eventually that will get passed into our module, and that will mean the module is happy to build. So let's go and do the same for production. Cool, so we've got that all sorted out. The next thing we need to do from the root level is to think, well, okay, how are we actually going to inject that backend thing I was talking about? Let's go and look at what I've done previously. You can see there's not much config in here, but let's copy and paste it and actually have a look at what's happening. So, first and foremost, it doesn't render very well in Vim. Generate backend, you can see it's a resource type, path equals backend.tf. So that is when it checks the module out, it's going to check to see if that exists, that backend.tf file. And then if it does, it'll overwrite it. And then in here, the EOF, everything inside of there is going to get written. So nice and simple. And you can see you've got a few interesting things here that are being added. So local Terraform token, that is something that needs to be defined because as you see, when I'm looking at this remote setup in Terraform Cloud, I need a way of connecting back, right? So this is how Terraform connects back. So I'll explain how that works. Also, you can see the workspace here. That kind of differs in the name that I've set up. So for this example, let's just change that. So the local example is going to be called local environment dash. In fact, it's just going to be local environment will be the workspace name. And let me just check that. So it will be workspaces. Yeah, that should be about right. So it'll be the local environment that gets appended, right? So that will be, now I've done this slightly incorrectly here. So what I'm going to do is I'm just going to rewrite it. So you can see here what I've done is I have the prefix, the Cloud Native Skunkworks, and then I would tend to have an environment. So let's change that just for simplicity. And I'll explain why in a little bit. So easily done. We can just go into here. So we'll set Cloud Native Skunkworks staging. Okay, and this is where it helps to take a bit of time to think about your structure because you'll then have to expand upon this structure once you've built it. So workspaces is set. Now, where do these things come from? Well, if we look back at the example, you can see there's a block at the top of this file. Let's write this block out ourselves rather than copying it over. The first thing that block refers to is something called regional config.hcl. We know about that, right? Because we have a similar one called environment specific.hcl. Makes sense. But why is that block here? Well, the important thing to remember is that when you're going to execute this in Terragrunt, we're going to jump in to the module level folder. And what will happen is that Terragrunt works backwards and it compresses all of these HCL files together. So effectively, you can see the commands find in parent folders, read Terragrunt config. These locals are going to be made available at the module level, and they're going to say, hey, where's this config file? And so therefore, having it in the root folder of the parent directory makes it available to the generate backend TF command. Now I know that's a lot to take in, so let's try and do something with that, and hopefully it will make a bit more sense. So Terragrunt TF, we've got our generate backend. Now we also want to define some locals at this layer. Now we're going to say, yeah, let's take the environment config, and we're going to use the built-in read Terragrunt config, and we're going to put find in parent folders. And this one's crucial because, as I said, we're not going to be working at the root level. It's going to be recursing back up until it finds the root level Terragrunt HCL, which is this file. Find in parent folders. Now we don't have a regional config. We've actually given them a slightly different name. You can see we call them environment specific. So we're going to go back in there and call them environment specific.hcl. So we've got that local defined. Now, if we want to extract something out of that file, we then have to define another variable. So we'll call the actual environment name equals, and that's going to come from the environment config. So it's going to be local, not locals plural, dot environment config dot locals dot environment. So what that's actually telling us now is if we look inside of something like staging environment specific, it's getting this out of it. So it's getting the staging suffix, and that is why it was important for me to call this dash staging, because if you look at the Terragrunt HCL, you've got that as the suffix on the workspace. So quite a few concepts to take in there. But let's keep going, okay? So as we go back to our Terragrunt HCL file, we've got that defined. There's something else that we're missing, and that is this Terraform token. Now, in the typical here's what I made earlier fashion, again, I'm just pulling it out of my local bash terminal. And this is nice because it means that it's not something I have to hard code into the demo. I can just put it in the README. You've got to have this set. So I have something called Terraform Workspace Token, and for posterity, I'm going to just add this in to the README, which is going to be Cloud Native Skunkworks Terragrunt, and we're going to call this requires. And we're going to put it's going to be Terraform Workspace Token. And it's going to be our, I believe, Civo token, which is the cloud provider I'm using for Terraform repository, but we're passing it through, okay? So this is what your Terragrunt HCL file should look at the root level. Now, we're still missing some stuff, right? We go into staging to Civo, there's an empty file. What's going on here, right? This is where we really need to link up the module. Now, if you go back to the documentation, we can look at this. It says Terraform source, and it's really confusing because it's using TRF and all sorts of stuff going on here. This is if you're using a module in Terraform Cloud or in the registry. We're going to use a module in Git. So we're going to assume that these are two Git repositories, maybe in GitHub. And in fact, I'll push them after this. So we're going to call this one CN Skunkworks Terraform. We're going to call this one CN Skunkworks Terragrunt, right? So what I'll do is I will push them afterwards. But before I do that, I need to set this up because it's gonna complain to me and say, hey, I need some parameters, what's going on? So let's jump into one we made earlier, right? So you can see that I have a very similar thing here. What you do is you define Terraform, and as you can see, you put your source. And this is where the syntax is a little bit tricky. So it's Git is the protocol, github.com. In this example, I think I'm going Cloud Native Skunkworks. Let me just check. Cloud Native Skunkworks, and the best way to do this in GitHub to find your organization is to go and look for it. So there we go. Cloud Native Skunkworks is the name of the org. I'm in fact going to create a repository while we're here, just so that we've got that for the video. So let's create that. We're going to call it Terraform, CN Skunkworks Terraform. It's going to be public. Great. And that can be, because I've got a private key to this account, I can use SSH, and we're going to pop that in there. Now we look back at the actual syntax, you can see that's not the end of it. You also need to provide it a tag. So what we'll do later on is we'll produce a tag. And also you can see you've got / /Civo/Kubernetes, so it's the module name, and then inside of the module is the second module path. Now in our example here in Terraform, we have a pretty simple structure. So it's just going to be Civo. right? We haven't got an inner folder. But if you want to walk down and have several layers of module directory, that's how you do it. So here it's just going to be called Civo and equals ref, and ref is going to be local.tag, and this is something we haven't talked about. Like, what is this local.tag? And that's really peculiar. And it's interesting because this is something that we'll probably want to use the same across Terragrunt, but I don't want to have to keep defining it, right? So we're using a parameter. And again, I mentioned that think of everything being squashed in Terragrunt, right? So when it's running from the module level, all of these directories are effectively being resolved prior to that. And so in a similar manner to the root level, knowing what's going on in the environment config, from the module level, you can see we're doing the same kind of thing. So we're saying, hey, find this file, find the tag name. Right, okay, so we don't have a file with a tag name, let's make one. So I don't think it's very logical that I would define the tag in each module in each environment. I mean, that's not dry, is it? We want to define the tag of the remote Terraform version we're using once, right? Maybe a few times if you've got development branches, but in this example, once, right? So we'll have a file and we'll call it, you know, terraform config.htcl, and that can live in the root folder. And all that config is going to tell us is the current version, the current tag available for Terraform, right? Because when we push to GitHub or an environment, we have tags, right? And these tags are a cut of the code at a particular point in time. And all that is going to tell us is which is the one that we want to use. So let's create that. So I'm going to call it terraform config.htcl. And I'm going to, again, use locals. And in here, I'm going to have tag equals. And I'll create a tag called v0.0.1. And that's it, right? Done. So we have that at the root level. Let's go back into staging and complete that journey. So now I've defined my tag in the root level. Doesn't exist yet. We have to push all that stuff. We will. Let's look at what else I had in here. So, okay, a similar kind of story. We had locals. Now I need to get that file. So again, terraform config, that's the variable name. Read terragrunt config. It's telling us that we're going to read an HCL file, find in parent folders. So wherever you are in the directory tree, that'll look up and try and find this folder for you. I think I called it terraform config.htcl. And then to fetch something from that, tag name is going to be local.terraformconfig.locals, so looking at all of its local parameters, and then it's going to be tag in this example. Okay? We've also got a couple other things that have been defined. You can see that we're invoking the regional config. So the regional config is being used in this particular example to fetch the environment name, and that environment is being used for the cluster. And that's useful, right? Because I need to define, is this going to be a cluster going to, you know, Europe or the US or Germany or some other environment? So in my example, I've got this staging cluster. Now I don't know if staging is an environment that I can use, so I'm going to just set that as an environment I know exists. And because I know how Civo Cloud works, I know that Lun1 is one of their examples that you can use. Rather than pulling that directly out the file, I'm just going to set that there. However, to repeat the example of how you open a file, let's do that again. So we didn't call it regional config. We called them by a slightly different name. We called them environment specific. So I'm going to follow that trend, and I'm going to have a new environment configuration, right? So what we do first of all is that we're going to open up our environment specific config, and we're going to say read terragrunt config, find in parent folders, and we're going to go to, and in fact I've got a spelling mistake there, environment specific.htcl. I'll just fix that spelling mistake. And then we're going to go to actually pulling out our token. So token equals local.environment, and I've got two spelling mistakes. It's not my day today. Specific, and then we're going to say config.locals.civo token. So that's the environmental variable that we defined earlier, and it's more for an illustrative purpose than it being something we have to do this way, right? So we've now got our token. What do we do for our token? Well, the token gets passed into Terraform because the token is how we create the cluster. Everything else I think we're all set with. So let's go down and look at how we have inputs. So what's going to happen here is we're going to say inputs equals. So this is going to be everything that we need to override inside of Terraform. Now, if we remember, we look at our Civo variables, TF, there are only 3, right? Civo token. We could have more, and let's change the cluster name just for illustrative purposes. So the Civo token is the variable, and that now is going to equal local.token. I'm going to change cluster name, I think it was _name, to cloud native skunkworks or CN skunkworks. Cool. Okay. So we did a lot of HCL there, and a lot of that was just hooking stuff up, right? So let's review. We have a root level terragrunt.hcl. No matter which module you call, it will always go back up to that root level, and it will inject the backend.tf. It also reads these environment-specific HCL files because we're calling them from the locals, and that will pass in environmental-specific parameters, and that could be something like the environment, right? In this example, I've had production versus staging, but I'm hard-coding the environment for staging to be London. I could set London production to be New York, for example. So let's try that a bit later on. The thing we haven't done, though, is push either these repositories, and that's completely fine because there is a working model where in Terragrunt, you don't need to push it to the remote just yet. What we're going to do is we're going to use local paths. So we're going to say Terragrunt plan -- Terragrunt source, and then we're going to put the relative path of CN skunkworks Terraform Civo. So it's the module path, right? Let's try it. It might not work. Let's see what happens. So what it's doing right now is rather than manipulating the folder on my local file system, it's making a copy of it in a cache. And that is exactly how it would work if it was pulling down the tag from GitHub, is it would make a copy in a cache, and it uses a little SHA on that cache, and it will then go and try and do the injection on the backend TF. It will try and pull the plugins, and let's see how far we get. You know, this is a first run. Things might go wrong. Another thing to do is to just double check while we're waiting that I've got the environment set up. Looks good. Another thing I'm going to do as well is I'm going to add this repository. So on the other tab, I'm just going to do a quick git init. Just going to add that remote. Just double check there's nothing I don't want to commit. Okay. Let's do a git add. Let's call this first. And there was actually a bunch of stuff that I shouldn't have in there. So you see here, I've got this whole bunch of modules inside that I don't want. So I'm just going to do an RMRF from the git folder, because actually that's easier than polluting the history. So what I'll do is I'll write a git ignore file. I'll put .terraform in there. So if we try again on that Civo directory, that Terraform file shouldn't be added, and I'll just put a star on the end just in case it doesn't let me ignore the state. So git init. Let's add the remote again. Let's do a first. And we're going to push that up to main. So this looks good. And if we refresh this, we can see that our very simple example is up here. And I'm just going to edit this and say, this is a simple companion example for Terragrunt. What we can also do is we can cut that release, and cutting a release is super simple. So what you could do is you could do git pull origin main, because we've just made a change remotely, and then I can go something like git tag new tag v.1. This is my first release. Save that out. Now git push tags. So now what we should see in GitHub is that we get this remote tag, which is great because eventually when Terragrunt wants to use this, it can use the remote. Okay, so we've got a bunch of stuff, and in fact, this is looking good. So you can see the plugins are pulled in, Terraform has initialized correctly. We have a required argument. Now this is actually specifically to do with the provider, but let's dig into it. You know, this is something you might run into. So this is Terraform. So I'm just going to go Terraform, Civo Kubernetes cluster, check out the docs, firewall ID. Firewall ID, okay, cool. So this is, I have to create a firewall. That's fine, I'll do that. I will create a firewall as part of my example. So Civo, I'm going to make it inside the cluster just so it's all encapsulated in one place. And I'm going to copy this example. Okay, so I'm hoping that we can iterate on this. Of course, it does mean that when I have a remote version now, I'll need to cut a new release. Great, looks like things are all happy. So Terragrunt, rather than Terraform plan, is driving this. And that is now injecting the values that I need. So you can see the name of the cluster is CN Skunkworks. Equally, we can see that the firewall that I've changed has been applied. So what I'm going to do now is I'm going to do an added my firewall. I'm going to push that on the remote again, and I'm pushing from master to main. My Git needs to be changed so that my main is on default. Anyway, let's cut a new tag, git tag a v.002, updated with firewalls. So this is a really nice way of working. So you're working as a team, you can cut PRs, you can check this, have an automated pipeline for this, and we're going to push tags. So what we're going to do now in Terragrunt is we're going to make a repository for Terragrunt. We're going to show how that would look, and we're going to hook those two things up. So I go back up to the root level folder, and we know now what the remote version is. Typically, when I work with this stuff, we'll automate this, so it will bump the tag version of Terraform. So now we've got a Terragrunt repo. So we're going to say, this is our first cut, so git init. And equally, in our project here, we're going to create a CN Skunkworks Terragrunt. And we're going to make that public. Cool. So I've initialized an empty directory. I'm going to add the remote. In fact, I'm going to do that with the right command, which always helps. And I'm going to do first commit. Just adding this stuff in. Let's do a commit. Oh, again, same problem. I was too quick. I'm going to do a rm the git folder, and you can see again, I've got a bunch of modules in here that I don't necessarily want, and those are inside of staging, Civo module folder. Then you've got a .terragrunt cache file. That Terragrunt cache file is where your modules check out to. So let's go .git ignore. So we're going to go .terraform, .terragrunt cache, because that will save you a lot of space if you end up doing that. So let's create a new Git repository. We'll add the remote. We will then do an add. We'll then say first, and then we'll do a push. And let's see what happens. Okay. Great. So we've now got our Terragrunt repo that drives our Terraform configuration repo. And I've just linked the wrong one, so let me find the right one here. Terraform. Cool. So what have we learned how to do today? Well, we've learned how to manage Terraform in a commoditized way. You could have 1 billion modules in here, and Terragrunt is where all the configuration lives, right? So you keep that really clean and really dry inside of Terraform. And we've also looked a little bit about how they work together. And because I was using the using the local path before, I was running that very interesting command of Terragrunt source, right? I don't need to do that if I want to use the remote. So I jump into Civo here. Let's say I'm in a GitLab or a Jenkins pipeline. I just go Terragrunt plan. Boom, done. What that is going to do is that is now going to pull from GitHub. It's going to pull that remote down into Terragrunt, just like it did from the local cache, but it's going to pull that locally here in this subfolder. And in this subfolder is where all the magic's going to happen. And that is where it's going to copy down the Civo module, and it's going to make things happen. So I hope this has been a useful demonstration. As you can see, it takes a little bit of fiddling with some of the parameters and understanding how Terragrunt works. I think that's the most complicated part of this, is understanding that there is a level of include on each folder. The documentation for Terragrunt is phenomenal, and I'm hoping that this is a little way to simplify some of that phenomenal documentation into a more bite-sized way, because there's a lot to it.